Then our final presentation of the session will be from Jiffer Harriman and two colleagues at the University of California, Boulder. Jiffer, looking forward.
University of Colorado, I should correct
Sorry,
that.
University of Colorado, Boulder. I don't know what came out of my mouth, but something different.
So the physical world all around us provides us with this rich sonic palette. The Kitsch-Instrument is a way to explore these sounds. It's also a toolkit that was designed to explore new ways of interacting with sensors and exploring programming as well as acoustics. I'm going to start with a quick demo video to orient us a little bit. You're going to see a quick setup attaching some solenoids to things. And then at some point you'll see one of the sensors getting swapped out. Whoops. And I missed. This is in the kitchen. My daughter's playing around here. So the Kitsch-Instrument lets you create music from everyday objects. It consists of a series of solenoid attachments to turn those objects into percussion instruments. It also uses a modular set of interfaces that lets you swap out sensors for different ways of controlling it. It was designed to be accessible for novices and open and extensible for advanced users. In order to achieve appeal for both these audiences, it was designed to have multiple points of entry so that you can make music with it right out of the gate. You can also explore programming with it. You can explore sensors, and you can explore the acoustics of these physical objects. It was made to be transferable so that ideas and skills that you get from interacting with it, as well as the hardware itself, can transfer into new settings. It's made to be transparent so that you can see how it was made, and it's made to be hackable so that it encourages exploration. I'm going to show two quick ways of interacting with it. First, this is kind of manual mode. Just using buttons to directly trigger the solenoids. And then in algorithmic mode, you're in control of parameters which are affecting the sound. I'm going to talk more about how that's working here in a minute. So this project is built on a toolkit for music that I've been working on called Modular Muse. Modular Muse consists of a modular set of hardware interfaces, which are interfaced to an Arduino board. You see down here on the bottom some buttons and some sensors plugged in. There's an LED, and they all use a single cable to plug in. And then the software side is a library for an audio programming language called Pure Data. And just quick show of hands, who knows what Pure Data is? A lot of people. You guys are out of the norm for the normal population. That's good. So for those of you who are not familiar, Pure Data is this visual data flow programming language. And in this case, these objects have an analog input coming in. It's controlling the frequency of a sine or of a waveform, audio waveform. That's being sent through a filter and out to the speakers, and then this filter is being controlled by another analog input in this example here. So the Kitsch-Instrument is built on a couple Arduino shields. The first one allows access to the interface modules that you saw a minute ago. The second one is the Solenoid driver shield, which you see here. And this shield is set up so that you can use the Arduino 5-volt power to drive the solenoids, or alternatively, an external power supply if you have bigger solenoids that you need to drive. And it also has headers and an option to add an XB if you want to drive this wirelessly. The solenoid attachments consist of a suction cup to attach to smooth surfaces, a stand for setting on horizontal surfaces, and a hanger which lets you hang it from rims and things like that. In the wild, we've seen the I've had the Kitsch-Instrument in front of kids at demonstrations as well as in workshops, and I'm going to talk just briefly about what I see in those settings. So in demonstration, kids will come up and usually, they like to get their hands on things. They'll hit the buttons and play with it, twiddle the knobs and see what happens. They don't usually unplug sensors and try new things out. But what they do is explore the physical and acoustic properties. So they'll take the solenoids and put them on different objects and try different things out. This kid in particular came back over and over again to try things out. In case you want to know what a spoon sounds like. And finally, I set this kid off on his career of cowbell playing. During workshops, there's more time to explore and to understand. And so in these settings, kids take more time to try out different sensors and understand how they're working, as well as digging into the programming to try and understand how the programming works so that they can make changes, and often asking, can I do this or can I do this with it? And the answer is usually yes. But of course, you have to then figure out how to get there. Okay, so this is a basic patch which captures the basic algorithm that I like to use to drive this thing. It's not as scary as it may look. Down here we have a comparator. A random number is generated once a beat, and then we have an analog input. And if the random number that's generated is less than the value being read by the sensor, then the solenoid triggers. Otherwise, it doesn't. So now I want to try really quick to see if we can all perform this. So it's the end of the day. Let's wake up for a second. So I want everyone to choose an instrument. You can clap, you can tap your hand, you pat your legs, or stomp your feet. So I'm going to, every time I drop my hand, then it's time to play. Okay, good job. Okay, so that was 100%. If you were playing along, then you were playing 100% of the time. Now I want you to think you're going to be a computer and randomly decide to play or not play about 20% of the time. So you're playing less. You're not playing more than you are playing. If that makes sense. That was confusing. Okay. And let's go. Okay, good. So some of you I think we're still playing every time. Some of you were probably just confused. But it was fun anyway. So now this last video shows this algorithm in action with some different sensors. So you're controlling density, and you're controlling the likelihood that it's going to trigger.
Can you do both?
And so it gives you a new way of kind of experiencing the value being read by the sensor. Okay. So future plans. For the last few months, I've been working with a middle school music classroom, and we've been doing some programming and other things. Moving forward, I'm going to be bringing some hardware in for them to play with, including this project. There's also going to be some more formal workshops to find out really what can be learned by playing with this, basically, and getting it into the hands of musicians and artists, including the Boulder Laptop Orchestra. And then finally, I plan on creating design files which will make it easy to recreate the attachments, the solenoid attachments, using 3D printing and or laser cutting. So to summarize, the Kitsch-Instrument lets you create music from everyday objects. It uses a series of solenoid attachments to turn these objects into robotic percussion instruments. The Modular Muse toolkit makes it easy to swap out different sensors for control and program new musical algorithms from PD. In order to make this tool, which is fun and accessible for beginners and flexible for advanced users, we made use of these characteristics. Wanted it to have multiple points of entry, wanted it to be transferable in other settings, wanted it to be transparent so you can see how it's made, and wanted it to be hackable so that people could do new things with it that I haven't thought of. If you'd like to learn more about this project, please go to modularmuse.com and or send me an email, or also stop by the demo and come and chat. Thank you.
Questions?
Hi, Daniel Ashbrook from the Rochester Institute of Technology. This makes me super happy. I love this. I'm curious if you have played around with recording loops, essentially. I'm reminded of how Katie Tunstall can play along with herself by live recording a loop on her guitar and then having that go into the background to do something else. I
haven't done that, but that's why I want other people to play around with it and see what they can do. I've done it, built a basic sequencer, but I haven't had a way of capturing performance and then basically turning that back into the solenoids. But yeah, that would be a really fun example. You could use maybe piezos or something to just physically beat on things and then have it respond to you.
And then as a follow-up question, I'm curious if you have actually made any music as such yourself with this.
I mean, yeah, you just saw some of it, but I've not recorded it to go along with other things at this point. I did use some of it in a laptop orchestra performance, so I guess that counts.
Cool.
Yeah.
Thank you.
A couple of years ago, Makey Makey came out, and it was, deemed as the inventor's kit for everyone. And it was very exciting to see people play the piano with bananas and so on. And what you've done now is taken this, this idea one step further and provided much more flexibility. But you've also, what I was really impressed by were your design principles, those 4 design principles that you, hackability, transparency, I can't remember the other 2. But I just wondered whether you've been able to show that in the initial evaluations that these are central to children's engagement and their ability to learn and understand the programming, the engineering, and also making music. So have you been able to kind of connect or show how your principles have fed into how kids engage with it?
That's a really good question. And I think that's basically the next step of this project, is to find out, is this actually providing multiple points of entry? I think the first one, it has been answered yes. There's a lot of different ways that I've seen people engage with it. But as for the others, I think more needs to be done, and I need to be able to really get a feel for what people are going to take away from it. Thanks.
So I have this theory that if you have one bit, one particular cadence, and you time it up twice or 4 times and play them at the same time, it would be really fun to hear. So I would like to maybe experiment with that. And then if that turns out to be interesting, maybe it's a chance to add in loops and a logic to it as a way to teach kids to program. So there may be something fun there as a thought.
Yeah, I don't know that I caught all of what you were saying. You're talking about basically new ways of controlling it, right?
So it's one sensor mapping into multiple solenoids and each doing slight variation. So the whole setup has the same base, but variety. Yeah, well, I mean, so that's all. I encourage you to come by the demo and we can talk more about different ways of playing with it, because I think there are lots of possibilities, and I'd love to hear your ideas.
Let's give another round of applause to Jiffer and all of the presenters in the session.